One of the things I love about Mr. Robot is that they didn't cut any corners on the realism of hacking. At the time of airing, the community, myself included, poured over all the details that came up on the computer screens to see whose real scripts and whose real exploits were included in this week's episode. I about lost my mind when an untrusted deserialization script of mine appeared on screen. But what is untrusted deserialization? The truth is, it's not just Hollywood magic. It's actually a really dangerous vulnerability, but unfortunately, it's also a difficult one to grasp. I wanted to take some time today to help demystify deserialization and talk about how contrast can help. Before we can talk about deserialization, we probably should talk about what serialization is and its purpose. So serialization is the process of converting a data structure or an object into a format that can be easily stored or transmitted. In other words, if you have two Java applications and you have an object in one application and you want it in the other one, you can serialize it, send it over there, and the second app can deserialize it, and voila. Now it has the same object in memory, just like the first app. All the methods and attributes are all right there. To further explain how serialization works, I'd like to use a Lego analogy. Think of a Lego spaceship you built. That is our object. Serialization is taking that spaceship apart, placing all the bricks in a box, and attaching an instruction manual. Transmission is mailing that box to a friend, and then reassembly, or deserialization, is your friend using the instruction manual and the bricks to perfectly rebuild the spaceship. Great, so serialization makes sense, but why is deserialization dangerous? Well, if the serialized object is user-controlled or untrusted, it represents input into the application, which carries risk, just like all other forms of input into an application. However, serialized objects pose more risk. We need not look any further than the Lego analogy to understand why. During the Lego deserialization, there was an instruction manual, and it gets used to remake the object. If the serial object is untrusted, then these instructions are also untrusted and therefore can be dangerous. Going back to the computer side of things, when an application attempts to deserialize, it doesn't just recreate the object, it's going to follow those instructions and may trigger other code. An important thing to note here is only methods available to the deserializer at that time can be accessed. Which brings us to our next topic, gadget chains. What the heck is a gadget chain, you may be asking? A gadget chain is a sequence of pre-existing benign methods found in the application's code or its libraries, frameworks, or so forth. And it's used to expand the scope of what is callable so that an attacker can perform an action they want. The idea is when you call some class or method available to you, it may include and load new classes and methods that you can now call. And if you continue to chain these calls together, eventually you may get to the point where you can call something that lets you execute a command, for example. We call this chaining gadget chains. They can both be well-known chains or custom ones unique to an application. Generally speaking, a gadget chain is how an attacker can take an untrusted deserialization vulnerability where they can't call anything impactful and tunnel their way through classes and methods so that they can reach something impactful, like a process spawn. So now that we understand what deserialization is, how can contrast help? Firstly, we can help by detecting vulnerable conditions. In this case, we'll track untrusted input, such as HTTP parameters, bodies, headers, and so forth, or external messages queues, and we follow this untrusted input to deserializers. And if that data arrives there unsafely, then we can alert defenders to the vulnerability by opening an issue within our platform. Secondly, we can detect if such a vulnerability is being exploited. We monitor for known bad gadget chains, as well as known bad behaviors during deserialization. For example, if a process is being spawned while an object is being deserialized, that's a bit worrisome. In the case of this vulnerability being attacked, we immediately open an incident for the previously identified issue, as well as bump the score of the issue due to its active exploitation. This attack to vulnerability correlation is one of the most exciting things about contrast to me. It can really help defenders prioritize and focus their efforts on what poses the most risk to their organization at a given time. And that's it. I hope you learned something, and I hope that deserialization has been demystified.